Hello everyone. In this tutorial, I'm going to show you how to perform a proper grade check when creating a Profile 8 hybrid remix using Dolby Vision metadata from web streaming services. Step 1. Measure both sources with MadVR. This is the most important part of this tutorial. You have to measure each pixel of the Dolby Vision Profile 5 video and the HDR10 video. Run workflow 6 for both sources. The script will use MadVR to measure all the pixels and will plot the data into a graph easy to comprehend. This is the best and most accurate way of verifying if the sources are the same brightness and if they can be merged together. This part is mandatory, and anything else you do cannot be considered a true grade check. The measurement must be done using exactly the same active area, excluding any letterbox from the MadVR analysis. You must crop the black bars for accurate average brightness data. Unfortunately, this process can take a while, but it's worth it. Profile 5 source requires Vulkan support. In a VSP mod, zoom for 100% for easily seeing the black border's edge. These measured values will be used later to edit level 5 when we inject the RPU. Unless you are using the UGUs with CPMA14 build or your TV internal player, all the other HDMI players will ignore the level 5 metadata. If the source is already cropped or doesn't contain letterbox, no further cropping is needed and the video can be measured accurately. Depending on your PC, cropping using ProRes might be faster, but the script default settings doesn't use it. You can enable that function within the script settings with Notepad++. Step 2. Extract the Dolby Vision RPU and compare the brightness measurement plots. Run workflow 1, skip the second input and select D. Now we have a brightness plot image of the two inputs and the Dolby Vision metadata. Compare the Profile 5 Dolby Vision and HDR10 brightness plots, and make sure both sources have the same brightness. Small variations are okay, but when the brightness doesn't match, you'll notice it immediately. There won't be any doubt, like in the comparison I'll show you in a few seconds. When compared to the original Dolby Vision metadata, there will be more differences, but they don't matter, because Dolby metadata are meant for playback and have restrictions, while MadVR simply measures the brightness as it is, without any limitations. As you can see here, the MadVR plot of Dolby Vision and HDR10 do not match at all. Dolby Vision has the original 4000 nits master, while HDR10 is a 1000 nits trim pass. This movie cannot be transformed into a Profile 8 hybrid using metadata from the web. If you still do it, the tone mapping will be incorrect, either darker or brighter than intended. Step 3. Find the delay in frames. The script has two modes, auto and manual. Auto mode should work for most movies, but sometimes, due to a long credit intro or a long shot, you may have to find the difference manually, which I'll demonstrate after running it in auto mode. Run workflow 9 and drag and drop the two inputs. The script will export a bunch of scene cut frames and attempt to automatically calculate the frame difference. This may work, but never trust the value. Always check the exported frames folder to calculate the actual difference yourself. Find two identical frames from each input and calculate the frame difference based on the numbers in the file names. Determine whether it will be a positive or negative delay. Remember this value, as it will be used for screenshot export and RPE synchronization during injection. If the script fails to find a difference automatically, here's how to do it manually. Run workflow 9.1 again, and this time select manual mode. Then, in AVSP mod, navigate through one video until you find an obvious scene cut frame, and locate that same frame in the second video. Calculate the difference using the frame numbers. Step 4. Additional optional grade check. Since we've already established that a proper grade check is done through MAD-VR pixel measurement, this step is optional. If you still want to do it, the workflow for that is 7.2. Drag and drop your inputs, enter the delay in frames, select auto or manual mode, and let the script run. Always export screenshots in their original form, in HDR, not tone map to SDR. Comparing to HDR sources in SDR doesn't make much sense. It's like comparing to lossless true HD tracks compressed into lossy C3. Besides, web browsers like Chrome and Edge fully support HDR images. So SDR tone mapping is not recommended and can even be misleading. By default, the script will not measure each frame as shown in this video, but you can enable that option in the script settings using Notepad++. I recommend uploading the images to a website that allows viewing them in native HDR. Firefox doesn't support HDR images and is actually completely broken since version 136. Do not check the Optimize Image option. This will remove the HDR flag, and HDR or SDR tone mapping in Chrome or Edge will no longer work. When the source brightness is different, it will be obvious, as shown in this example. You can create the same heat map as in this video using Workflow 7.3. Expect color differences with iTunes WebDL, since all iTunes WebDL have a color shift. Reds appear brighter, and overall colors can look slightly desaturated. This is caused by Apple's flawed encoding, which uses the same static color reshaping metadata across all encodes. This doesn't matter for Profile 8 hybrids, as that metadata is discarded and only applies to Profile 5 playback. Having static metadata isn't inherently a problem, but using the same reshaping metadata for every encode is what causes the color shift. Here, you can see the red shift in native Dolby Vision compared to other streaming services or Profile 8, and then the same file processed using libplacebo losslessly. The reshaping metadata is effectively meaningless and misleading since Profile 8 doesn't include this metadata. This is why the issue doesn't apply. You can compare any Apple TV stream with HDR10 or other streaming services and you will always see that color shift. Step 5. Inject and Remux. Now we're ready to inject and edit the Dolby Vision into the HDR10 Bluray Remux. Run Workflow 1 and input the HDR10 Remux, followed by the Dolby Vision RPU metadata. Level 6 is useless and can be skipped. Sync the RPU according to the frame delay we found earlier, and edit level 5 based on our previous letterbox measurement. That's it, just wait for the script to complete. You can double-check your final Remux media info and verify if all the RPU edits were applied correctly with Workflow 1. Step 6. Verify the metadata and video synchronization. Run the final Dolby Vision RPU metadata file through Workflow 1 to export its sync cut list. Then, run the video through Workflow 9.1 to index the frames for accurate reading. Check random frames at the beginning, middle, and end of the video to ensure the metadata stays in sync throughout the entire video. Sometimes, web and Blu-ray releases can have a different frame order. Note that Dolby Vision metadata doesn't include a frame rate, it's based on frame order. So, 24 FPS versus 23.976 FPS doesn't matter, as long as the frames remain in sync with the video. Do not create a Profile 8 hybrid without verifying the grades, not even a P8 WebDL hybrid. I've seen many cases where the HDR10 layer and Dolby Vision metadata do not match even within the same streaming service. I've seen many release groups doing just one or two screenshot comparisons in SDR and calling that a grade check. This is incorrect. You must measure both sources in MadVR, and the screenshots must be in HDR. It makes no sense to compare two HDR releases outside of their original form. Always verify you're seeing cuts after injection. Frame order can sometimes differ between web and Bluray releases. Visit my Google Excel sheet. I've probably already checked the Profile 8 remux you're about to create.